Welcome back to 5G RF Features Explained. In this episode, we'll explore one of the most iconic and powerful 5G technologies, massive MIMO and beamforming. These two features together enable 5G's ultra-fast speeds, high capacity, and reliable connections, even in the dense urban environment. Let's start simple. MIMO stands for multiple input, multiple output, a system that uses multiple antennas at both transmitter and receiver to improve data throughput and reliability. In early systems like LTE, we had 2x2 or 4x4 MIMO. That means 2 or 4 antennas transmitting and receiving in parallel, creating multiple independent spatial streams. The key idea: MIMO sends different data on each antenna using same frequency, exploding differences in radio channel between antennas. Now, 5G takes this to the next level, introducing massive MIMO, which may use tens or even hundreds of antenna elements at the base station. Why massive? Because instead of 4 or 8 antennas, we now deploy 64, 128, or more. This dense antenna array allows precise spatial control, enabling the network to focus energy exactly where it's needed, improving spectral efficiency dramatically. Massive MIMO is particularly beneficial in middle band and high band, where wavelengths are shorter and compact antenna arrays are feasible. Now, let's talk about beamforming. The technique that gives massive MIMO its smarts. Instead of broadcasting signals in all directions, beamforming steers radio energy toward specific users, like a flashlight instead of a bell bulb. Using phase and an amplitude control across antennas, the base station can constructively combine signals in the direction of the user and then cancel out interference in others. This means better coverage, stronger signals, and higher throughput, even at the cell edges. In 5G new radio, beamforming is tightly integrated with massive MIMO. Each user gets a dedicated beam, and those beams can dynamically change direction as the user moves. Beamforming can be implemented in several architectures. Analog beamforming, one RF chain, uses phase shifters. Digital beamforming, separate RF chains per antenna, most flexible but power hungry. Hybrid beamforming combines both for a balance between performance and efficiency. In millimeter wave bands, hybrid beamforming is most common due to hardware constraints and energy efficiency needs. Together, massive MIMO and beamforming bring multiple advantages: higher spectral efficiency, improved coverage and signal quality, better interference management, more users served simultaneously. These are key enablers of 5G AMBB, enhanced mobile broadband, and URLLC use cases. Massive MIMO and beamforming truly represent the heart of 5G RF innovation, transforming how wireless networks deliver capacity and precision. In our next episode, we'll look into dynamic spectrum sharing and reframing, and how operators transition from LTE to new radio seamlessly. That's all for today. If you like this video, please subscribe, share, and like. Thank you.